Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
and Molly Hudash. Hello, everyone, and welcome back to another episode of the Jack Westin MCAT podcast with your hosts, Mike and Molly. In this episode, we are getting into arguably, and now I'm even going to argue with myself, one of my favorite topics. It's hard to pick a favorite. I love cars, I love Chem Phys, I love Psych Soc, but today we're talking about Biochem, not just the content, which is so much fun, but we're talking about the section itself, how to crack this section, because as we were just talking about, Mike, this might be everyone's favorite material, but objectively, this section has the hardest passages out of all four sections. Like, not even a question.
I see. Here's the thing. It's so funny, like hearing you're like, oh, it's tough for me to pick a favorite because you love Chem Phys, you love Psych Soc. For me, there is no debate. I love Bio. Like, I will say that with my chest. I'm like, hands down, Bio, my favorite section because it's so interesting. It's so cool. Even I remember when I was studying years ago, like it was always Bio was the coolest and fun section. But those are also places, like you said before, where the passages can get so convoluted. Oh my goodness, the kinds of terms
I love it.
I
love it.
There's so much to look at there. Sometimes they bring up new terms, they bring up new abbreviations. You're like, oh my gosh, what's going on? But while at first it can be really overwhelming, you learn to really love these things. It's kind of like every passage is like a cool study where they're bringing up new things, new pathways you can learn in the passage. And so while many people a lot of times they get super stuck on the overwhelm, what our goal today is to kind of show you a path in order to figure out the section so you can actually learn to love the passages like we do, like learn to actually like gain that confidence. And like kind of a little preface about Bio. We kind of mentioned this for the Chem Phys, and for anyone who doesn't know, because I know at the time of releasing this episode, it's very early on. A lot of people studying. It's gonna be around, I don't know when we release this episode, end of September-ish, I think. And so the Bio section is one of the 3 science sections, and it's got 59 questions, and you have 95 minutes to complete it. Okay. So there are 15 questions and 15 discrete questions and 10 passages, and all the rest of the questions are associated with the passages. And so while discrete questions are a part of the exam, those 15 discrete ones, there's no passage, so you can just do those. A large portion of the questions are passage associated, so we need to become very comfortable with reading bio passages because most of the questions will be associated with them. Something that we kind of hit on if you checked out our Chem Phys, Mastering Chem Phys section episode, we also like to chat about where our questions are going to come from. This is very important when prioritizing your studying or when trying to figure out what to study. It's very important to know how they're going to test you, right? I think this is Sun Tzu is like this. I love like The Art of War, Sun Tzu, big fan. It's legitimately a book about war. But part of the first step for tackling any
we're at war with Biochem.
We're at war with the MCAT, really, with this exam. I for certain thought about it this way, but to fight an enemy, you have to know your enemy. You have to understand what you're up against. And so in terms of the questions that they're going to test you on, they kind of broke it down into kind of like 4 types of things they can test you in the bio section. First is going to be biochemistry, obviously, because it's in the name. They're going to test you on biochemistry. 25% of your questions will be biochemistry related. 65% is going to be purely biology related, while 5% is Gen Chem and 5% Orgo. Orgo. If that's how you felt from me just saying that, we just did an episode on that last episode. Go check that one out about what you actually need to know for Orgo. But you can see largely in Biochem, it's largely biology and biochemistry. Like, I mean, really largely purely biology with a little bit of chemistry sprinkled in. Just a little bit of chemistry because there's so many connections that you can make. And so I always want to preface this, and something we prefaced last episode, like when we talk about Chem Phys, these are the questions are from these percentages, the 25% biochem, 65% bio. The questions can be from these. The passages, however, can be from anything that are that are related to those topics. They're not going to do Psych Soc very much in the biology section, but they can have a whole bunch of biochem passages, even though only 25% of the questions are from biochem.
Yeah. And I feel like it's important to recognize that, like, when you're going to see general chemistry and organic chemistry, it's not going to be like, oh, let's get into something like super specific and granular within these, right? It's like the 5% that you'll see from Gen Chem and OChem respectively is going to be on things that are connections. So like acid-base chemistry.
Hmm.
Guess what? Amino acids, as
Oh
it
my
sounds
goodness.
like,
Hmm.
are all acid-base chemistry, right? Like,
Hmm.
of course, there are acidic and basic side chains, but even if we just consider a single amino acid, there are acidic basic groups just as part of the general structure, right? The backbone. So like there are topics that really do kind of blur the lines between a biochem application and a gen chem or ochem application. And that's really what they're going to test on, especially with ochem.
Hmm.
Separation techniques is big, right?
Yeah.
Like there are lots of ways that we can integrate gen chem and ochem without you even really realizing it. So I don't want you guys to hear that and be like, oh, chem and bio, no, right? The same way that in
Mm.
bio or in chem phys, there was actually a little bit of bio in there. It's the same deal, right? It's testing on those connections, and that's really what we want to focus on. Also, I think it's so interesting, Mike, that from when you were studying, your mindset was like, I am at war with the
Oh
MCAT.
yes, I was
I,
at war with the MCAT. Are you kidding? Especially cars. Like for me, cars, I was like, this is my enemy. I need to defeat this enemy. That was my mentality.
that is so,
I am not a friendly like, oh, this is great. No, I was fighting for my life. I remember
that
that for
is
certain.
That is so funny because I feel like when I first started studying for the MCAT, I almost felt like Jane Goodall. Like I had like my little notepad and I'm like watching this weird animal like, "Oh, okay, okay, that is not what I want to do." Like, what are you doing? Okay, okay. Think this way. Like taking notes like a naturalist, like, "Oh, okay, like don't take too much time on a figure. That doesn't do good things for
Right,
me." Like,
right,
"Oh,
right.
okay. If I approach it quietly, then it works." Like,
No, I'm
tread
going
lightly.
spears in, like I'm just jumping in. No,
Yeah.
different mental approaches because
Violence, curiosity
yeah,
makes
basically the
sense.
same thing, 100%.
But
But
biochem, you got to stay on your toes because
mhm,
ultimately, and this is, I feel like, why they make it so difficult is they know that majority of students that are applying to medical school were bio majors or biochem
mm,
majors, right? They're not to say that you can't be lots of other types of majors, right? It's pretty awesome that I have a friend that was actually a Spanish literature major who went to medical school, right? Like you have to take the prereqs, but you can major in anything. That being said, a lot, right? Majority of students are bio, maybe biochem, maybe some subset of bio or biochem major when they apply. So they know that you've taken at least a couple courses in this. They know that if you're applying to medicine, you probably enjoy this stuff. That being said, the whole goal of the MCAT is to separate students, right? To give you a situation that you are forced to adapt to that's incredibly unique of a challenge. Their goal is to separate you. If everyone really loves it, that means that their job of separating is even more important, especially given that a lot of people have like upper division coursework in these topics. Like they need to not just make the content widespread, but they need to make the passages hard. They need to see, okay, you have probably a greater understanding of these topics than in many cases chemistry and physics or psych or soc. Now it's the real war begins or the real
see,
challenge begins to
now you
understand it.
understand the violence perspective. I'm like winning Molly over to the
Oh, no, 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 no.
violence. Anyway,
You
sorry,
will
no,
not. However,
we do not promote violence. But
yeah, no,
and
this
I
is the
think
challenge.
and I think you bring up a really good point. And I think bio kind of really brings in not only the content that people have been like studying, but also the skills. It shows the skills
Yes.
that maybe that they were lacking from those classes that they need for medical school. Because a lot of the times in these undergraduate classes, when you're doing bio and like cellular bio, molecular bio, you could memorize your way through it. You could
Yeah.
use that skill, and that's how you were able to get through it for a lot of these undergraduate classes. And
Mhm.
that's why when we look at like average scores, like on the sections of the MCAT, the one that's actually scored the highest on average is Psych Soc,
Yeah.
because that hits on the skills that you've been practicing all in undergrad, which is skills like memorizing. You do have to memorize
To a greater
to a
extent.
greater extent. No,
Memorizing
it's
is
not
not enough
completely.
to,
It's not complete, of course, but there's a greater amount of memorizing in psych social, just knowing your terms in psych social. Not 100%, but it is
you need to know
necessary.
how to apply them. Mike,
Of
don't
course.
tell them that they just need to
Of course.
memorize.
Okay.
Will
Hey,
not
no,
improve
no,
your
no, no,
score.
no, no. I want to make it very clear. You don't just memorize in psych social. Of course, you
Okay.
need to know how to apply it, but you do. There's a lot. I think it's a greater proportion of your success is memorizing if you
Yeah.
just know your term.
Yeah.
Whereas in the sciences, like Chem, Phys, and Bio, largely memorizing is not going to help
Yeah.
you to the same
Gets you
degree.
nothing.
And that's, I think, where a lot of people struggle in bio. It's like, yeah, like you're like, wait a minute, bio is what I did for my undergrad. Yeah, I'm doing better on psych soc. Why am I doing so poorly in bio? It's because it's testing a lot of different skills that maybe we didn't develop in undergrad, but that we now have the opportunity to develop now when studying for the MCAT, and that will be helpful for us for medical school, which is understanding and knowing
Yeah.
how to apply. That's, I think, where there is more room to be made, more skill to be gained in bio. And a lot of that will come in these passages, how to extract information and apply it. And so that's what we're really going to be
Yeah.
looking at today is like these bio passages. What are we going to see in these passages? What are we supposed to be taking away and applying to these questions? That's going to be really what we're focusing on.
Yeah. And for context, like Mike and I each have been teaching the MCAT for 4 or 5 years plus, right? Like
Mhm.
for a long time. And one of the favorite things that I do with students, if I know that they need to work on strategy, the first types of passages that I will go through with them when they're learning strategy for the MCAT is Biochem.
Mhm.
And it's
Mhm.
because I know that you're probably more comfortable with this material. You probably are not going to see a passage and be like, oh my God, okay, right? Like
Mhm.
you're not going to necessarily have that same visceral reaction to the material. And yet it's really hard and
Mhm. Mhm.
you can't really get through these passages effectively without learning and picking up strategy. So like this is a great place to start if you're early on in your MCAT journey and you're like, okay, I know I've got pretty significant content gaps. I haven't taken psych soc yet. I haven't, maybe I didn't love chem phys when I was in school, whatever. Start cars. Can never start that early enough. But also in terms of making your way into passages, look at the BioQ packs, right? Get kind of a from the AMC or from our Q bank, right? Like get your toes wet with biochem because you will be forced to learn strategies that then can be applied to other sections. And because you might not have that same visceral reaction to like a fear of a particular topic if this is something you're more comfortable with. Um, that being said, again, structurally and objectively, these passages can be tough. They really, really can be. So I feel like it's important to walk through the types of passages that we'll see. But, and I know when we were talking chemistry and physics, we had very distinct sort of passage personalities. Like, okay, an OChem passage will look like this. A Gen Chem experimental passage will look like this. A physics experimental passage will look like this, etc. But with Biochem, you're going to see the same common features tested and presented in passages of all subjects and topics. So I feel like it's better to start with general features. I will say Biochem is a very experimentally
Mhm.
heavy section. Not that you can't see experiments everywhere, but these are very detailed experiments often. They can be quite complex and there tend to be multiple. So you might have experiment one and then experiment two and then experiment three, right? You need to be ready for these. So I feel like it's good to chat about this first, right? Anytime you get an experiment and you see a research figure, most often it's going to be preceded by a paragraph that tells you what the goal was and then what the methods were, right? If we were to walk through, again, maybe you start with background knowledge, then you establish some area of study or some area of curiosity, or you establish a hypothesis, or they might directly tell you a research question, which, by the way, if they use the word researchers at the start of a sentence,
Oh my goodness, yes.
pay attention because
Mhm.
it's almost, it's not in every passage literally, but it's almost in every passage that the research question where they tell you, researchers investigated the effect of the independent variable on the dependent variable. It's almost literally a direct quote like that. Like
Mhm.
they
Mhm.
they do this all the time. It's always researchers starting the sentence. So funny. There's different words they could use after that: investigate, hypothesize, assessed, whatever. But researchers something, the effect of the independent variable on the dependent. Make sure you know what your research question is from that preceding paragraph. The methods themselves, students tend to get really lost because they're going to give a bunch of, experimental technology and all this stuff that they're going through. You might get a question, but you're going to know exactly where it is. Don't get lost in the details there, right? Most often, they're going to test you about the question and the findings. You will know exactly where to go if they ask you about the methods, right? So don't spend 15 minutes there trying to figure out, okay, well,
Mhm.
why would they use this to study this, right? Like
Mhm.
keep moving through methods. And then, of course, when you get to your figure, title, axes, units, trends. If you weren't clear on the research question in the preceding paragraph, as a reminder, the title is a great refresher on what your research question is, right? It's very common that the title will be a restatement of the research question. That doesn't mean, though, that you don't have to look for it in the passage. One of the biggest pieces of advice or almost warnings that I give to students with BioBiochem is it's quite common that the terminology that they will use in the research question that's in the paragraph can actually be different from the axes and the terminology that they use in the figure. So they could say, let's say, sympathetic activation. I want to study the effect of scary movies on sympathetic activation of individuals, right? That's the research question. And yet on the figure, you are looking at the change in heart rate.
Mhm.
That is not, when they ask you questions, they will probably use the word sympathetic activation. They will not use heart rate, which means you're going to look at the figure and you're going to be like, wait a minute, that's not even what I studied. It is, though. Okay, so just beware. Sometimes the research question and the figure are going to use different
Mhm.
terminology. That's why we always look for the research question, anyways. If they
Mhm.
are different, you need to know that change in heart rate is how we were studying what was in our research question. That I've seen really throw a lot of students off, right? And then, of
Right.
course, if you get multiple experiments, make sure you know the different things that are being studied in each, because if
Mhm.
you get a question, you know it's about data, but you don't know which experiment. You want to know what was being studied, right? How are these experiments different? What are we doing that's different between experiments, so that you can figure out where best to go to find the
Yeah.
answer.
Yeah. And I think a lot of students like they kind of like self-admit like, "Oh, I struggle so much with the data interpretation. When I see some data, I get so overwhelmed." But what I find a lot actually, it's not actually the data itself that actually is the overwhelming part. Where I think that usually the issue is they don't even know what they're looking for. Right? It's like they kind of like skim that paragraph because I you kind of mentioned this one thing where it's like, oh yeah, we don't want to drown the details of the methodology of the research
Mm-hmm.
question. But a lot of times I actually see the exact opposite. Where people just glaze over it. It's like I didn't even
Mm-hmm.
read it. And I was like, well, if you didn't read it, how are you even supposed to look at the data? Right? A lot of the times
Mm-hmm.
people who say they struggle with data, normally the fix isn't, oh, look at the picture differently. It's why didn't we read the methodology beforehand so you know what we're about to look at before you even look at it? Look at the research question, look at the title, so you have more
Mm-hmm.
context when you look at the data, right? It's not about the picture itself. You have every, and I'm listening, and I say this about legitimately everybody that's listening right now, you have every ability to read that data. You're just not taking the steps in order to get there. We talked about
Mm-hmm.
that last a lot in the last episode. I love this analogy where it's like you're trying to get to the top of the stairs, but you need to take the right steps in order to get to the top. You're not going to jump there. You're just not going to just look at the data and just know
Yeah.
exactly what's going on. You need to take the steps, read the methodology, so you know what is even the research question. What are they even trying to do? What's the hypothesis, right?
Mm-hmm.
Then read the title. To check your axis, look at your units, then look at your trends. A lot of people just look at the data and they're like, why can't I figure it out? And so definitely, like I can't echo it enough, Molly. Read that research question. Look at
Mm-hmm.
that methodology. Don't skip it. Please don't skip it. Actually read it. It's funny. A lot of students, even in tutoring, like when I tutor students, they're like, Mike, what does this data mean? And I'm like, I don't know. Let's read the passage before. Let's read the paragraph before to figure out what they were even doing. Because even when I'm looking at that data, I can't just interpret it without reading that paragraph beforehand to know what are we even doing with this. Um,
Yeah.
and so while experiments, and that's a lot of times what students complain about is the experimental part, there's
Mm-hmm.
also what we hear a lot in biopi passages and what we see a lot in bio passages are these really long pathways Oh
I
my
love
goodness.
pathways.
Like when you have these like, oh, protein X, it phosphorylates this really cool kinase, and this kinase activates this transcription factor, and this transcription factor inhibits this activator, and like all of these things, these pathways. And what I find a lot with students get so overwhelmed. They're like reading it and they're like trying to read through it all and trying to keep it in their mind. And they're like, oh my gosh, there's so much going on. I'm gonna answer the question. And then we go into like avoidance, where it's like, I'm just gonna skip it and keep on going. I'm just gonna glaze and keep on going, where it's like, hold up, slow down. When we're reading our passage, this is something we've iterated before, but really want to hammer on here. Use your scratch paper. Oh my goodness. Whenever I say use scratch paper in any passage, I always get the same pushback. It's always the exact same thing. It's, oh, I
Takes
don't have,
too much
it's too much
time.
time. I don't have enough time. Like, and it's funny, I was guilty of the exact same thing. When I was first going through it, I started how everybody else started. Let me just highlight in the passage and then go into questions. But I would find I wouldn't remember all the stuff in the passage. I would miss things all the time in the passage and then get these questions wrong. Where I got this great advice, which was just start writing it down. And I had the same kind of pushback at the timing, just try it out. And what you find is what will happen is probably will take maybe an extra 30 seconds to write these really quick notes and the entire passage, an extra 30 seconds. But these questions become so much easier. You don't have to be jumping back and forth between every single time. While you're reading it, writing down the pathway helps you to move through it much more efficiently. Maybe it will take you an extra 15, 30 seconds, maybe in terms of the passage reading, but the benefit that you get, the security that you now understand what's going on a lot better and can now answer these questions so much more better, you actually end up saving time. This goes back to our favorite saying, Molly, right? Slow is smooth and
And
smooth is
smooth is fast.
fast, right? Like this is the idea where, yeah, go slowly in the passage, write out that mechanism, that whole pathway. Again, not in like, don't write out whole sentences, please. Arrows, please. Use short form, but at
Yes,
least write it
that's what
out.
I was gonna say.
Right, yeah, use short form. Don't write a whole sentence. I shouldn't be able to read it in 10 minutes. It's just for now, right? And then, but by doing that, you go through the passage more efficiently and you do these questions way more efficiently. So use your scratch paper, please.
Yeah, and I feel like it comes down to something that I hear all the time. And I hear this in science, and I also hear this especially in cars,
Oh,
which
yes.
is I teach cars office hours for all of our self-study students and our course students. And so often, my number one question that I get, and it's science too, but I feel like I get to the end of the paragraph and I have no idea what I just read.
Mm-hmm.
And like in a cars session, right? Or in a cars passage, you're thinking like, I don't really understand what the argument was. I don't know what was bringing up, but that's equally true of science of like, there was so much going on in this. There were so many details that like, I get to the end, I'm like, okay, I'm just going to move on. And I feel like the advice is the same. You need to be more engaged when you read, but also how do you just be more engaged? So many of the things that are, advice that we give to someone who's struggling just sounds like, okay, like,
Mm-hmm.
oh, you're struggling, just stop struggling. It's like, oh, you're
No,
having
just do
trouble
it.
reading, just read better. Like that's not helpful.
Oh, why did I
One
think of
of the
that? Oh.
one of the concrete things that you can do is to actually try, right? As you read, whether it's a signaling cascade or an experimental design, whatever, as you're reading, if you feel like, oh, wait, this is kind of important, how can I smush this whole sentence into a couple words and then jot it down? Right? It's very, very helpful. We have whole strategies for that in cars, but for science, it's very useful as well, especially when describing new molecules, abbreviations, and especially relationships,
Mm-hmm.
right? Like you said, if you have this molecule binds this one and activates this, and then causes this molecule to become active, which then activates this one, draw it out, right? You do not need to use the entire molecule name, right? Until you have two molecules with the same first letter, you could just put P and C and M and B. Oh no, there's another B. Okay, well, this one is now BR. Like you can abbreviate, right? Create a mapping language for yourself, right? An arrow with an actual arrowhead typically means activate or create, depending on the context. Again, you only need to be able to understand this for a couple minutes, right? And this will still be fresh on your mind if you're engaged with it when you read, right? If you have an arrow that has a flat head, right? It's typically to inhibit something,
Mm-hmm.
right? Create your own like
Language, kind
key or
of.
your own
Yeah.
glossary or your own
Mm-hmm.
language and use it, right? I don't mean that you need to take notes Of course, if you do end up using a lot of your scratch paper, you will always be able to get more. It's kind of a hassle in some test centers depending on when you need it, but you can, right? If you need more scratch paper, they will give it to you. Don't be worried that you're going to run out. They won't let you keep the old scratch paper. They will trade you, right? So keep that in mind, but you can always get more if you need it. Don't be worried about that. That's the other pushback that I get sometimes is I don't want to use my scratch paper because what if I run out and then I don't have any more? You will have it, okay? It's a great way if you hear the advice to, to lock in and to engage and just give the passage your full attention and you're like,
Wow.
thanks.
Oh, I'm
I'll
just supposed to
just get
lock
better real
in. Let me
quick, right?
let me
Like
just lock
this
in real
is
quick.
this is a concrete thing that you can do, right? And I will say, coming back to what we were talking about memory and encoding, writing compared to highlighting
Oh my goodness,
is
yeah.
so much more active, right?
Hmm.
It's also much faster to navigate in the questions. If you have a picture versus you highlighted a bunch of terms in a cascade in the text, it is much faster to look down at your drawings than it is to go back and reread because ultimately the answer could be a relationship from anywhere in that paragraph. Whereas if you've drawn it, you just look down and find that molecule name, right? So it's a tool that will take time. Okay. Don't expect if this is the first time that you've ever mapped a signaling cascade before that you'll be able to do it in 1 second. It may take time to learn how to do it. But the beauty is, at the time that this episode is posted, there are no test dates for like 4 more months. Okay,
Hmm.
so you've got time. This is the best way to use that time. It's to actually invest in strategies that will help you when you take your test. Even if it takes a little more time while you learn it, that's okay because no one at this point in the testing cycle is testing tomorrow or this Friday or something like
Hmm.
that.
Hmm.
Slow is smooth and smooth is fast. Learn it the right way, or learn it in a way that is going to benefit you truly and deeply. And you'll have such an easier time when full links start to run around or, your test is right around the corner.
Yeah, and I think you're hitting on something about habits there that I really want to kind of
Mhm.
reiterate, where a lot of the times people say like, "Oh, I'll just focus on strategy when I get there, when I get to my practice phase or when I get to my exam
Mhm.
phase." But at that time, a lot of times, Molly, it's too late. It's too
Yeah.
late just because you have so many ingrained habits. You've been
Yeah.
going through your practice questions in your content phase the same way. So I actually had a student who was like this. Like they went through their content in the same way, so that when we actually started to practice and we're trying to implement strategies it's not sticking because they just keep on going back to their old habits. So that's why if you're starting now or even if you're early, even if you're midway through your studying, like if there are habits that you have
Never.
right now, it's never too late to change it. But the earlier that you can change it, the better, right? Don't just say,
Mhm.
"Oh, when I start doing passages, I'll do it this way." No, start now the right way so that when you get there, when you start doing exams, you don't have to learn how to do it. You've already been doing it the same way. You've already
Yeah.
built up those strategies and built up those habits. And I think that's, yeah, so important to start now with strategies, not later. And I
Yeah.
also love that you brought up like the whole idea of engagement because I hear that so often. Oh, I need to
I know.
highlight in the passage in order to stay engaged. Where, sure, like you are now highlighting things, but are you actually understanding what you're highlighting?
Mhm.
Like it's
I mean,
so passive.
highlighting might be better than just staring at it,
Sure,
but
sure.
it's only a little bit better than just staring at it.
It's like, yeah, you know what? One is greater than zero. You're totally
It's a it's a
right.
marginal improvement. It's still
Marginally,
an
hey, it's
improvement,
great.
but it's
But like writing is
yeah.
so much more engaging. Where a
Mhm.
lot of times we have this barrier because it's hard. It's
Mhm.
way more active. It's so much easier just to say to highlight. You're totally right.
Mhm.
Anyone who says that is totally right. But th we do the hard things because we end up with a better outcome. And when you start getting used to the hard things, it actually starts becoming a lot easier. So
Oh yeah.
do the hard thing. Write down the relationship in the passage. Do that. It's gonna be uncomfortable. I can promise you it's gonna be uncomfortable at first, but do it and you will get used to it and you will benefit in it.
Yeah. I was listening actually to a TED Talk recently that was
Mhm.
all about the beauty of discomfort and
Mm.
how oftentimes, other than like actual like scary
Pain.
discomfort, like
Yeah,
okay, that's
yeah.
different, but like
Yeah.
discomfort that comes from challenging yourself is the most beneficial thing for you and your development. Because
Mm.
discomfort at its core, again, and I'm not talking about like, oh, I'm uncomfortable because someone's following me home or like
Yeah,
I'm
different kind of
uncomfortable
discomfort.
because it's 20 degrees outside and I'm in a, like in shorts and a tank top. No, no, like obviously those are different types of a
Mhm.
discomfort, but discomfort when you're putting yourself in a challenging situation is you acknowledging this task is not in my comfort zone. I I'm in a situation where I have to adapt, and that is scary sometimes, but it's also like the single most important thing if you want to grow, if you want to get
Mm,
better, if you want to learn, if you want to develop as a person or as a student, right? If you want to improve your MCAT score to apply it specifically to this, right? Like if you're at a 495 and you really want a 510, if you just keep doing things that you're comfortable with, you will never get there, right? The beauty of discomfort is that you're trying something new, you're opening yourself up to a new experience. It might not feel great if you try it and you struggle,
mhm.
but guess what? If you fail at something, that's a gift in the palm of your hand saying, "Hey, we weren't ready for this. How can we get ready?" Right? This was a tough thing for us. What steps can I take now so that next time I come across this situation, it's easier for me or I have a greater likelihood of success, right? Discomfort is a beautiful thing, right? You could walk your way there. We need to be able to perform this way when we ultimately take our test, whenever that looks like for you. But don't shy away from things that you don't feel ready for, right? Don't wait until you feel ready, essentially, because you probably will never feel ready if you
Ever.
always stay in your comfort zone.
Hmm.
Part of the beauty of the MCAT process is that so many of these things will take you out of your comfort zone, but you can grow so much from this process if you open yourself up to it. That's actually one of the reasons I love teaching the MCAT.
Hmm.
It can shake students to their core and make
Truly.
you question a lot of assumptions you make about yourself. But it really does. If you let it, it will teach you how to learn and it will teach you how to grow in a way that's pretty useful as a physician, as a medical student, and as a human being. So
Hmm.
just a little note there.
I was like, that's so inspirational. Like that, that's so true. That's not just MCAT advice, that's just life advice. But applying it to the MCAT is so, so important as well. Like, because again,
Mhm.
it's so ubiquitous. Do the hard thing when it
Do
comes
the
to
hard
strategy. Do
thing.
the hard thing, and you will see the benefits. Not right away. It won't be
Mhm.
tomorrow that you see that.
Yeah.
Practice these things, practice these really intentional strategies, and that's when you'll see the benefit. Right?
Yeah.
Oh,
Invest in the right things,
exactly,
basically.
right. Like your
Yeah.
strategy, which is great. And if you want opportunities to practice that strategy, go to our totally free Q bank. We have
Yeah.
thousands, over 7,000 questions that you can start practicing. Because a lot of people are like, okay, that's so great to practice strategy. I need passages to do that. And maybe I'm not ready for the AAMC. Well, maybe I want to save the AAMC. We hear that all the time. Sure, great. If that's what you want to do, practice with our JW passages for now,
Mhm.
right? Practice with this totally free material. Get used to implementing your strategy so that when you're ready for the AMC passages, because I think we used this analogy before that AMC passages are like fine wine, and they're like you want to you can't appreciate the fine wine until you actually have built kind of like an understanding of passages. Build your understanding of passages, JW passages first, so that when you actually use the AMC passages, you actually have a strategy. You can actually make use out of them, other than just doing them with no strategy and essentially wasting them.
Yeah. I will say though, and actually we did an episode about this
Mhm.
months
Months
ago,
ago
right at
on
the beginning
yeah.
of our podcast on how best to use AMC resources. I actually think that things like the bio Q packs, there are
The Q
two of them,
packs.
the physics Q pack and the chemistry Q pack. Those are actually great to get practice with. They are older material. I like to
Hmm.
think of them as kind of MCAT training wheels or like
Sure.
AMC training
Hmm.
wheels. As you're making your way into it, those are great places to start
To
because this
start.
material is from the older exams. It's a lot more topic focused. They're less complex than what you're going to see today, unfortunately. These are from before 2015. They're more than 10 years old, right? But they're a great way to engage with the AMC material and not spoil anything really, right? Again,
Hmm.
they kind of are like the AMC's training wheels. They're not the most complex in terms of strategy, but they are a good place to kind of learn. They're very similar to our fundamental passages in our Q bank
Hmm.
and our fundamental questions because again, our fundamentals are meant to be more topic specific. So like if you just studied amino acids, cool, go to our amino acids area within biochem in our fundamental question pack, right? So that's the idea. There are some AMC that you could try early, but when we talk about like the section banks,
Oh
things
yeah. Yeah.
like that, the exams,
Those are
oh
so, so
God,
valuable. And
do
that's why
not do
if
not
you're
start.
and I think that's actually a really great price for if you are starting early now, like if you're earlier in your studying process and you've heard about the AMC, maybe even probably already bought the AMC, maybe at this point, and you're like, I've got so many resources, how do I even use these resources? check out that episode. Maybe we can
Yeah.
even link the episode in like the description to check, maybe editors, I don't know, to check it out, to check it out. And so we can actually walk through which ones should you actually start with, which ones are really representative that you really don't want to do early, and which ones are much more better when you're starting AMC to start off with.
Mhm. Yeah.
So yeah, go
Yeah.
check that out. So what a great callback. What a great callback
Yeah.
there.
We've been
But
having
cool.
way too much fun on our tangents. We
Yeah, I know
gotta we
that
gotta U-turn it back.
we're bringing it back now. We're bringing it back. So we've covered kind of like the general properties of a biopassages. We know we're
Mhm.
gonna see. We know this is not a maybe. We know we're gonna see a lot of pathways. We know we're gonna see a lot of experimental data. No matter the type of passage, you will likely see either one or both of those things.
Yeah.
And so, but now we can actually get into the kind of the passage topics, some of the passage personalities that we kind of
Mhm.
see in bio. It's so funny when we were making these, we were actually just Molly and I, we actually just went through like all of like the section bank of like bio, and we're like, yeah, like this falls under this personality, this falls under this personality. They all fall under the following, I think, four personalities that we're
Yeah.
about to outline here. And these personalities, I think, are very topic focused. Like, what kind of topics are you going to see? They kind
Yeah.
of fall under one of these ones. And kind of
Yeah.
the first kind of like bio passage topic that you're likely going to see is the molecular bio passage, right? A molecular
Hmm.
bio passage is one that's very focused on like DNA replication, transcription, translation, gene regulation, like these kinds of like, oh, we regulated something or we mutated something. That's a lot of the times you're going to see these things. Like you're going to see things like, oh, there was a mutation in this gene line, or we had a knockout, we knocked out this, let's see what happened. Or, oh, we added this, like we use a recombinant technique. Oh, we added this gene, let's see what happened, right? Where these are the sorts of passages where we're manipulating things and we're saying, okay, how has the RNA transcription changed? How has the protein expression changed? These are the sorts of passages where you can see cascades here. You can see a lot of experiments here. And so in here, again, and I think this is just going to be a reiterating theme, use your scratch paper. Please, right? Like
Yes.
there's going to be a lot of like, oh, we knocked out this thing. Oh, what happened? Write it out, especially if you see it in like an experiment. Like use your data interpretation skills. If you see a clear trend, like, oh, we knocked out this and then therefore this transcription went down, write it out. Little note on your scratch paper so you have that trend in your mind.
Yeah. And I feel like you're hitting at something really important, which is in these molecular biopassages, oftentimes they're like, we're curious about what this thing does, so let's
Get rid
mutate
of
it, or let's
it.
knock it out, or let's knock it down, or let's destroy it somehow, or temporarily turning it off, right? Like oftentimes the goal of these passages, like the research question that's going to be posed is, what happens when I turn this thing
It's
off?
kind of, it's
Right?
kind of chaotic a little bit. We're just
It's
kind
a
of like,
little chaotic,
let's just throw it
right?
and see what happens.
Yeah,
Yeah.
it's like I'm trying to figure out the function of a particular protein or a
Mm,
particular gene or things like that, and maybe in a particular stage in development, etc. Like I want to understand what is the importance or the value of this thing.
mhm,
So oftentimes I'm going to remove it or I'm going to add it to a situation that does not currently have it. It's super fun, right? But lots of experiments. You will see
mhm,
lots of experiments, and you want
yeah,
to understand the research question here, especially so
mhm,
that you can interpret the data. Oftentimes, the data here gets to be a little confusing
mhm,
if you don't know what your goal was to start with. Because they're
exactly.
just going to say, I started knocking out this and that and this and that, and I saw this happen, but then this happened. And I'm like, oh my God, like,
Yeah. What?
what
Wait.
were we
What?
even studying? Right? Use your scratch paper. Make sure you understand if we're talking about a pathway, like what gene did we mutate? What protein product is typically associated with that gene? If I mutate this gene, why do I see the change that I do? Probably because that protein was, upregulated or downregulated or changed in activity or context somehow. Make sure you draw your cascade if you have it, and make sure you find that research question. Again, this is why we covered those things separately.
Mhm,
Those skills are actually present in all four section or all three science sections, but they're going to be found in all of our bio personalities, right?
mhm,
The next one that we're going to see is biochemistry. And this passage personality is actually almost identical to the biochem sorts of passages that you see in Chem Phys. Again, biochem makes up a big chunk of both sections. If you have a biochem passage, oftentimes it's going to be experimental. You're usually going to see something about enzyme kinetics, or metabolism. You might be talking about inhibiting certain chemical reactions. Oftentimes, when we see experiments, they're going to be related to Michaelis-Menten or Lineweaver-Burke. So you're going to see a lot about kinetics. Again, we could be talking about metabolic dysregulation, or what if you add this particular molecule, how will metabolism adjust, right? It's all about for the most part, pathways and reactions. So you're going to need to use your scratch paper quite a bit here.
Hmm.
If they give you a reaction diagram, of course, no need to draw it, it's right there. But they don't tend to do that as often in BioBiochem as they do in ChemPhys, right? You may see like, more reaction cascades given to you when we talk about OChem and Biochem in the ChemPhys section. Biochem, they don't usually give you anything. They
Yeah.
expect you to draw it. Okay, so be
Hmm.
ready for that. Um, and with Biochem, as far as it relates to Biochem, not ChemPhys, I feel like it becomes even more important to see, to pay attention during the read, to be drawing while you read as much as you can. If there's a buzzword that you like, make sure to take note of it if you want to highlight it, whatever. Because the questions for these biochem passages, especially the biochem experimental passages, they tend to give you questions that you can anticipate pretty well, right?
Hmm.
Like if they tell you, hey, we've been studying this enzymatically catalyzed reaction, and we, in order to study it, added compound A. Compound A binds to the active site. It's a substrate analog for this reaction. And then we see a Lineweaver-Burke plot with and without compound A. You can almost guarantee that they will ask you a question about what type of inhibitor that was, right? And
Hmm.
you could get it in two ways. You could look at the Lineweaver-Burke, or it binds to the active site. It's a competitive inhibitor, right? Like
Right.
there are times that like as you get practice, especially in biochem experiments, they give you certain pieces of information and you know exactly what they're going to ask you and you know exactly the answer. Okay. You won't always do that, especially when we're talking about other passage personalities, but especially with biochem, I feel like it's a lot more common than when we talk molecular bio or the other two that we haven't yet gone into.
Right, right, right. And I think your that point about like your ability to predict the questions, when you have done enough really intentional practice, it's funny. I was actually just I think I mentioned this before. I was just talking to a student, like legitimately yesterday. Her exam is this Friday, and I've been working with her for like 3 months at this point. And she's like, yeah, at this point, like all these biochem passages are just kind of the same thing at this point, where it's kind of like they bring up the same buzzwords. They kind of based on the buzzwords, you can kind of are you know what questions they're gonna ask. So it's just not a surprise anymore. And when I heard that was like music to my
That's
ears.
beautiful.
That's like music to my ears because that's exactly what the goal is. Where
Mhm.
she's done enough intentional practice where it's like, yeah, as long as you have that strategy and you use the same strategy, the outcome's usually the same. Where yeah, they're gonna ask something about inhibitors if they bring up an inhibitor. They talked about they talked about knocking out something. They're probably gonna ask me about the function of that thing based on the experiment. Like they kind of you get these same tropes. And that's why I love this kind of series that we're on where we're talking about the tropes because you see them so often. So, and maybe someone listening is like maybe a little bit newer on like in their studying where they haven't really recognized the tropes yet. But as you continue practicing intentionally, you will recognize these tropes. And therefore, as long as you're doing these strategies that we're talking about, that's when you really get the benefit. But coming back to start now with your strategy so you can actually benefit from recognizing the tropes. Don't start later.
Yes.
And I think that kind of brings us to kind of the next kind of passage that we'll see. We've talked about the biochem passage, we've talked about the like molecular biology passage, but now this is when we get to like those cellular passages or the microbiology studies, where we see a lot of like signal transduction. We see a lot of cascading pathways in this one. We see a lot of cell cycle checkpoints. I'm a little bit biased because my research was in cell cycle checkpoints, personally. But we see a lot of like bacteria and viruses in these kinds of passages, right? They have like drugs or mutations. We added this antibiotic or we added this different drug. Okay, what was the outcome of that drug on this amount of virus, right? A lot of pathways here, really a lot of pathways here,
Mhm.
especially with these signal transductions of, oh, this where we had a situation where, oh, maybe a ligand bound to a membrane receptor. Oh, that activated, oh, this protein. Oh, which activated this next protein, which activated this next one. Oh, then that caused an increase in the amount of whatever, right? You see a
Gene
lot of the
expression or something.
expression, or and that could link to back to that other past type, or it could even cause something that isn't related to transcription or translation. Maybe it changed something about the inactivation. Oh, that activated this protein, and now we are now releasing some toxins or something like that. We're in vesicles or something along those lines. And so in these ways, again, this is why we did those general like those general traits, because again,
Skills.
this is where there's going to be a lot of pathways. So yes, please write them out. If we're
Yes.
sounding repetitive, there's a good reason for that because there's a very good reason for that.
Yeah.
Yeah, we want to make our stance very clear on what you should be doing. Those two things are critical and that we see students miss so often.
Yeah. So
Um,
pay attention to research in the
Absolutely.
way that we talked about, and then use your scratch paper.
Exactly. That's relevant to all of these sections.
Mhm.
But a lot of the times they'll also, in these pathways, maybe they're going to mutate or inhibit one of the middle paths, one of the middle proteins, and say, okay, what do you think is going to happen? Right?
Mhm.
That's when it's really important to understand, if there's an experimental design where they're like, okay, we want to see what happens, how important that protein is. Is there another pathway that doesn't involve it? Understand your independent dependent variables. I think that's always the case when it comes to any experimental study, but especially when we're knocking things out or when we're changing things, I think it's really important. Like when you're doing taught, really make sure you understand what is it that we're manipulating. Right?
Yeah.
Are we making multiple changes? Are we making certain changes to certain types of cells? Like maybe we have multiple independent variables, for example. Maybe there's one cell that has this knockout, like this gene mutated, and one cell that doesn't. Let's and then we added this drug to both cells. So we added one situation where we add the drug, another situation where we didn't add the drug to both those conditions. Already verbally, this sounds like a lot's going on, but that's why you need to track it down. What's our independent variables? Do they have the mutation or not? Another, do they have the drug or not? And then you can see the effects. What actually happened? What did we measure? Making
Yeah.
sure that you are tracking these things and when you're starting, even writing them down, write down your independent dependent variables. When you're starting, maybe down the line you don't need to do that, but just getting into that habit of to identify those things, I think is really, really critical.
Yeah, and I love this particular passage personality because oftentimes, and I've seen so many like this, especially when it relates to like a bacteria or a viral entry
Mhm.
mechanism or like how they are pathogenic, like how do they enter the cells, how do they cause dysfunction in cells? I've seen so many. The number one that you need to know is HIV. Like I would know the HIV, the whole pathway because I've seen it be the context of multiple passages, and I believe it's in the AMC outline. Like it'll say
Mhm.
viral mechanisms in parentheses, e.g., HIV, right? Like for
Yeah,
example, HIV. So I
HIV is
think
one you should be familiar with.
it's
Yeah.
worth knowing. I've seen it in a lot of passages, but honestly, I've just been waiting. I'm waiting on our MCAT for it to pop up that someone had a passage about COVID. Like I'm just
Ah,
waiting for
yeah,
it
yeah, yeah,
because
yeah,
like it's obviously not going to be like a discrete question, but these every passage that you read, and this kind of comes back to why BioBiochem is so fun, all of these passages that you're reading are adapted from scientific papers or
yeah.
scientific
Hmm.
literature in some way, right? Like I think within this in this personality, so to speak, the cell and molecular or the cell and microbiology studies, I think this one it's more common than in others to see something that might not even have data or experiments.
Hmm.
Like just this is the start to finish of this process, right?
Hmm.
If you have something like that, please draw it, right? Like
Hmm.
all they want you to know is how this virus enters and causes problems in the cell. Sometimes they won't give you an experiment, in which case you are entirely responsible for that pathway. And that is the primary thing they'll ask you about. I'm just waiting for someone to say, I had a COVID paper or a COVID
Hmm.
passage in my BioBiochem, because I feel like they'll do it. I
If they
kind of
haven't,
thought they
if they
would.
haven't already, if they haven't
If they
already,
have, I feel like they have. I just haven't heard about it yet.
exactly, yeah.
They don't have it in any of their materials yet, but who knows? We get, by the way, there's a new AMC exam coming out at the end of September.
Mm.
September, I think it's 25th, 26th.
I mean,
One of those 2 days.
as of releasing this episode, it might, I think,
Might
because
already
this
be out.
episode's releasing like on the 24th, so it might be like around the time when this releases when that new exam comes out.
Yeah.
Yeah,
Exam 7. They're shuffling names. Just keep an eye on the AMC website. They're giving us a new exam. Maybe we'll have a COVID passage. Um,
exciting.
anyways, as a MCAT nerd, that excites me.
Mm, mm,
But our final passage personality that you should be expecting to see is really the broader sort of organ system level sort of passage, right? So like more based on the physiology and organ systems, right? A
mm,
passage on the circulatory system or the respiratory system, right? On the kidneys and the, renal nephron
mm,
system, the digestive system, the musculature, right? Or even things like the neurological system, right? The nervous
yeah.
system. That especially you can get questions in biochem, but you also get a lot of questions on that in psych soc. Make sure
Mm.
you know your nervous system,
Oh
right?
yeah,
Because
I think
that
we did an
and in
episode on
and
that.
in
Yeah.
chem phys too,
Mhm.
right?
Yeah.
Nervous system is a high yield system to know because it
Mm.
can show up in any
Testable.
of the three. Yeah. So keep that one in mind. But typically, right, you will also get things on like broader organ systems. Like you might get one on like, particular types of pathophysiology, right? Like, hey, we're talking about resistant hypertension here, right? Like that's not a particular cell. That's not one particular biochemical pathway. We're talking about something that is felt on the realm of an entire person, right? Or if we're talking about like a big endocrine pathway, it's not just about one cell. It's not about the chemical reactions that occur when that hormone binds to one receptor, right? That would be one of our different passage personalities. But sometimes we get broader questions and broader passages that talk about entire organ systems. And oftentimes when we get passages like this, they will apply this to something like physics or chem, right? It's actually very similar to what we talked about in our Chem Phys episode, where we said oftentimes you could even see a or a passage in Chem Phys that feels like bio, where we're describing a system like this, and then your questions are about physics or about chemistry. It's like the physics of fluids in the respiratory system, for example. So you can see things like that. You might see a passage on like dialysis, right? That would be, basically blood filtration that is not being done with your kidneys. Maybe, you had a kidney transplant that failed, or you have kidney disease or whatever, right? Like things like that are interesting applications, and they often tend to be medical, which should be interesting to you guys as future medical professionals. But make sure that when you see these unique contexts, be ready. This is not just going to feel like a textbook, like, oh, yeah, the liver has this important function. No, no, they're not going to give you stuff They're going to give you, again, oftentimes either medical treatments or medical conditions, which is pathophysiology. Your organ system is not acting like you would expect it to. And now they're trying to see, how well do you know that organ system? Why is it behaving this way? What kind of drug might help fix it? Things like that. It's not medical knowledge. You haven't been to medical school yet. It's all going to come from those core principles. But again, it's application when we see questions like that and passages like that. It's not just have it memorized and be ready here to regurgitate it to get your score of your dreams. So
Right.
if you get new material, if you get something you've never seen before, the nutshell of our discussion here is don't panic, right? You
Hmm.
will see things that you have never seen before, but hold on to the things you do know, right? And just ask yourself, how does what I know apply to this? Or how does this apply to what I know? Look for
Hmm.
those connections and hold on to those, because that's where the answers are going to come from.
Right, right. And I think that's where a lot of the overwhelm we were talking about before from BioBio comes from, is from
Mm,
focusing on all the things we don't know. It's like
yeah.
that's why a lot of students like struggle and feel like, oh my gosh, BioBio is really overwhelming. Either they're trying to keep the Cascades all in their mind, or there's like, oh my gosh, there's all this new information I don't know. Well, you're probably not meant to know that new information. The
Yeah.
AMC loves throwing new stuff at you. Well, yeah, just focus on what you do know. Yeah, you don't know about this wild new mechanism, but hey, you know what the circulatory system is, right? You know what the core of the
Mm.
circulatory system, see what you can apply. So that's a huge, huge piece, focusing on what you know, not on what you don't. Right.
Yes.
And that kind
Yeah.
of like brings us to like the common things that we see, the common struggles that we see, and common mistakes that we see the students make in bio. A lot of these are very similar to Chem Phys, but there are some that are kind of like very bio specific. Um, and I guess there's one that I know that you really like to talk about, Molly. But like when it comes to like for what I see a lot of the times, one of the big things, and this came up in Chem Phys, is ignoring those cascades and tables that we were talking about. Right, we've made it very clear how we stand on what you should be doing in the passage and the
Mhm.
questions. A lot of people, and I see that hear this so often to this day. Again, I want to make a like a campaign or something that we can like get rid of this strategy
Sign
of
my
just
petition.
that please just stop skipping the passage. Just stop skipping
Yeah.
the figures and going straight to the questions. It is so prolific on like Reddit, for example. I don't know if I can say Reddit.
Yeah.
On Reddit, where it's like, oh yeah, this is what I did to score a 528. I just skipped the passage and went to the questions and then went back if I needed it. Well, here's the problem. The questions don't owe you to tell you what's in the passage or not. Right? How do we even know if the question is from the passage if you haven't even read the passage? We see this so often, and the students are like struggling. Again, the reason I feel so strongly about this is that we see students struggling all the time,
Mhm.
using this strategy, and they think it's because of them. They think it's a failure on their part, when it's just a problem with the process. Where once we change the process, they end up flourishing, and we're like, why is this a thing? Or for hey, you know what? If that skipping the passage when the question is working for you, go for it. I have just seen way too often that it doesn't work, so I don't even recommend people even start there, truly.
Yeah.
So please, please, if you haven't heard a theme yet in this episode, don't skip the experiments of the Cascades. Please read them, and please actually take the time to understand them.
Yeah. And
Mm.
I think I love watching, watching us get so passionate about these things. I think with strategy, it's really easy to get passionate because if when you've been doing this for as long as we have,
Mm,
it's like you can't really succeed on this test with no strategies, right? And
mhm,
so often like the things that we do because they feel comfortable for us are actually holding us back. Even if like, oh, hey, I'm getting a score, I'm getting a score that I'm pretty happy with. Maybe you have like a 507, 508 and you're like, I could be happy with that. Like I don't need to start doubting my strategies. What if, though, over the next couple months, if you shift something, you do something that feels a little less comfortable, you take a chance on a strategy that we're talking about, maybe you could get to a 517 or a 518, right? Like
mhm,
just because you're doing, you know, how you're happy with now, that doesn't mean that you can't get better, right?
mhm,
It's not a bad thing to, be getting the scores that you want. It's an amazing thing, but I never want students to feel complacent, especially if you've got months. Try it out, right? Never get too comfortable of like, I don't really need to get better. I don't need to make this change. I don't need to give this a try. We've all got the time in this moment, right?
mhm,
And this is the time to try new things. On the flip side, right, we talk a lot about strategy, and we've really hit home how important it is in biochem. One of the things that makes me passionate
mhm,
is allocating study time. Um, and I fell into this trap myself, to be honest with you. I've mentioned it multiple times over the past couple months because we've done a lot of related topics on the podcast. But like when I first started, OChem and physics terrified me, right? Before I even took a full length, before we didn't have I predate our content diagnostic, unfortunately. Like before I really even figured out where my problems were, um, I was just like, okay, half my study time is OChem and physics. The other half will be passage practice. That's silly. That's silly, right? Because it's such a small percentage of your test. That being said, when I thought about studying biochem, I'm like, I was a bio major. Like, I don't need to study that, right? Like, that's stuff that I like. I don't need to study that. I did. Okay. Like, one of the things that I get passionate about with this section in particular is so often this is the section that people enjoy, or these are the subjects that people enjoy. So we're like, I might not need to study it as much. And typically, students fall into one of two categories. Either I like this and I'm scared of everything else, so I will only study biochem. I don't want to look at the things that I'm actually weak at. That's not good. We need to reprioritize. And I also see the opposite of like I was. I'm fine at biochem. That's not my area of concern. I'm not even going to look at it. I'm just going to look at this. Both of those situations are problematic, right? We need to be using the performance data that we have of I'm getting this percentage accuracy, and when I do biochem questions, I'm getting this percentage accuracy with chemistry and physics. These are the topics that I'm struggling the most with. Those are the things I prioritize. Okay, so just because biochem are your favorite topics or your favorite subjects does not mean that it's not worth your time to take another look at them,
mhm,
especially because these passages are tough, right? Don't skip it just because you like it, I guess is my keynote there. And also don't wait to practice it.
mhm,
Sometimes we start with a thing with other topics and we're like, oh, bioback, I'm gonna be fine. I like those topics. Start early. Again, I love to start students when they're developing strategies. Let's start in biochem because
mhm,
not only do you like it more oftentimes, so it's easier to identify strategies because you may be more comfortable with the content. Also, sometimes it's a wake up call of this was my favorite and I thought I knew everything I needed to know about this, but actually, this is not what I thought it was going to be,
yeah,
right?
yeah.
Don't wait to practice. And also be careful when you're allocating time to study. Don't neglect it. Don't overfixate on it, but don't neglect it. Use the data that you have on your performance to decide where your time goes,
Mhm.
basically.
Yeah. Yeah, there's like a Goldilocks zone where it's like don't neglect it, but also don't spend all your time there. And I think there was something kind of you hinted on it, and I want to really focus on it right now, which is another mistake, and it just kind of came to mind because I saw this like a lot in this just past like in this past semester, where a lot of the times our mindset when we start a passage is also a reason why we struggle a lot of the times. Where a lot of times I see a lot of students start a passage already thinking, man, this is gonna suck. Like I hate like bio passages I struggle so much with. It's gonna be super complicated, it's not gonna be fun. I'm just gonna slog my way through it. And already it's kind of like a self-fulfilling prophecy at that point. If
Yeah.
you believe it's gonna suck, it's gonna suck. It's gonna be the worst thing. It truly will. And so the first thing, and this is something we overlook, your mindset when you go into a passage is huge. When you go into a passage, try to think, wow, this is going to be really interesting. I know that sounds corny. I know that sounds cheesy. Try it. Like genuinely, when I'm working with a lot of tutoring students, I remember there was actually one student, I remember her so specifically, where she was doing really well in bio passages. She was doing extremely well, like 129s, 130s consistently on her exams. But then all of a sudden it dipped, right? Her score dipped one time. And you would think, oh, one dip, not that big of a deal. We can fix that, whatever. But then it began cascading because of that dip. She began to fear the bio passage. She was like, oh no,
Yeah.
I'm going to have to do this again. And then that kind of that trend continued where the fix wasn't a strategy thing. It wasn't like her strategy was the same, but how she thought about it was different. Where all we need to do is try to enjoy the passages again. Try to think, wow, this is gonna be really interesting. At first, fake it. Just genuinely try to fake it. Think, wow, I'm gonna really try do your best to really enjoy it because eventually you'll find, well, wow, you actually genuinely start to enjoy the passages. It's this weird thing, but it is true. So this is a lot of the struggle where it's not like a specific strategy or content issue, but how you set yourself, how you frame your mind before you start the passage is huge. Please make an intentional effort. Try to enjoy these passages. Then you will end up genuinely enjoying them.
I know. It's so funny because I feel like this is true of every single section. And
Mhm.
again, especially in cars where you're getting something that you truly oftentimes don't necessarily care about. And it's like the whole fake it till you make it. And it's like, okay, sure, I'll just decide I like it. But it's like, find the angle, right? Like in cars, like you will probably never see anything discussed about this topic ever again. You probably will never be talking about this particular ancient Greek architectural design, right? Like you probably will never see the play-by-play of this particular battle of or of the Mediterranean fleet of the British army at this particular time period. Like you'll never see this again, right? It's kind of cool that you could spend 5, 10 minutes reading about something that you will probably never see again. In
Mhm.
this case, with biochem and with the sciences, it's really cool that you are seeing research that might not ever, right? You might not ever see this again, right? Or this could be a major foundational discovery that leads to something super cool in the future, right? This might be, you might get inspiration for research of your own, right? You might see this and be like, I didn't know that, right? It's cool. It is cool. And you could see it as a task you have to complete, which then makes it boring. Or you could see it as like little bite-size learning modules,
Mhm.
right? Like not that you need to memorize it and internalize it.
Mhm.
You're going to be tested on it in a minute, but not in 3 days. You don't have to
Mhm.
put it in your long-term memory, but let it spark your curiosity, right? Again, you have to open yourself up to that, but I think it's really cool when you do let it in because
Mhm.
you're probably never going to see something like this again.
Mhm.
Right. Most tests are not formatted like this. It's very rare that
Exactly.
you get these little bite-sized little nuggets
Little
of
pieces.
knowledge. They're cool.
They are cool. And I
It's
thought it was
super
so,
cool.
I thought it was so, especially in cars. And I don't know if this was you, Molly, but I remember reading cars passages on stuff I've never seen before, on authors I've never seen, on ideas I've never seen. But then I would notice those things in my day to day. Like I remember
Yes.
there was
Hmm.
like an author. I remember like Kafka. Like I like this author wrote
Hmm.
Kafka. And I'd never known who they are. And I was like, I don't know who Kafka is. It seems like he talks about some pretty negative stuff. I don't know. Like in the passage I was reading. But
Yeah.
then I heard it in like conversation or in like a movie or something. And I was like, wait a minute. I've heard that name. Wait, that was from my Cars
Mhm.
passage. And it became really cool seeing the stuff. Like, and maybe those things were always there. But as soon as I actually did a Cars passage on it, and then I actually saw them in real life, it became such a kind of like, oh, this is really cool. Like I remember, oh, there was one about oh, during the war, there were religions that were based off like planes dropping boxes for like soldiers. Oh, what are they called? What are they called? Oh, I'm gonna remember the name in a second. But it was
Okay,
like a
we'll come back to
yeah,
you.
but it was like a certain religion that I'd never heard of. That was as a result of American industrialization. Really, really interesting thing. Never heard of it. But then I saw like on TV about someone doing a news segment on it. And I was like, that's really cool. That's really cool. And that's specifically on cars, but also I saw that in bio. I remember cholera toxin was really, there's a passage on cholera toxin in the AMC. Then I saw it in like someone discussing it in real life. And I was like, oh, I actually know exactly what that toxin looks like because of that one passage on cholera. And so
Mhm.
like again, it was like little things like that where when you actually enjoy it and then you internalize it, it's actually really enriching to do that. Again, this sounds so corny, I know, but once you do it, oh, it's so, so, so cool.
Yeah. I feel like it gives you a whole new layer of understanding of the world around you. Like to this day, my favorite class that I ever took in college was a vertebrate zoology class where they literally took you out on a hike and showed you the birds in your area. All of a sudden I was seeing all these random birds that I'd never even noticed before. It's the same thing. Like you're getting clued into a bunch of random piece of information and then you start to see it everywhere and it's pretty cool, right?
Right.
Now years later I still see birds and I'm like, "Ah, haha, I remember that."
Ah, yeah,
Right? Like it's
right.
it's just fun. If you enjoy the process, you have to do it anyways. Here's the thing. You have to do it anyways. You have to study the MCAT anyways. You have to
Mhm,
put in the hours to see the score improvements that you want so you could call the MCAT done and go to apply to medical school. You might as well find the fun in it.
mhm,
That being said, we've talked a lot about passages. We've talked a lot about strategy. You do need to learn content, right? We need
mhm,
to make sure that we understand the topics that are very likely to show up. Last episode that we did with ChemPhys, we kind of just basically, speed run a couple. I think we should do that again. We'll start with
mhm.
biochem. Big thing. Number one, highest yield thing on the MCAT,
Huge.
amino acids,
Hmm.
right? Please,
Hmm.
you need to know these forwards and backwards. You need to know every R group. You need to know the three-letter abbreviations. The one, you need to know the full name. You need to know the properties of the R groups. You need to know the acid-base chemistry. You need to know how these can be connected to separation techniques and analytical techniques. Like any possible way that you can connect anything that you're learning in your content phase to amino acids, do it.
Hmm.
Because this topic can be looked at from physics and gen chem and ochem and obviously biochem, but also bio. And you know what? There are even amino acids that act as neurotransmitters in your
Hmm.
brain. That's psych, okay? Single most important thing on the MCAT, know your amino acids.
Right, right.
Okay.
And people have probably heard this. Sorry, I want to jump in because I actually just had a student test and they were like, oh my goodness, there was like legitimately last weekend. They were like,
It's
there was so many amino acid stuff. There was so much amino acid stuff. Like
it's
it's so
crazy.
ubiquitous. Anyway, I just had to
Yes.
jump in because like you might think, oh, is this old information from like no, no, no. Like this
No,
last
no.
weekend, there was that
Mhm.
case.
Yeah. And the thing is it connects to everything and that's the
Mhm,
reason, right? But
mhm,
amino acids, do not skimp. Actually, call back to a free resource that I made a while ago. There we have a basically our own free version of Anki on our website. It's based
mhm,
repetition flashcard platform, but I made a complete comprehensive amino acids deck that tests that material forwards
mhm,
and backwards and
mhm,
there's like six different subdecks with different ways for you
mhm,
to, like
mhm,
remember, active
mhm,
recall, things about amino acids. That's free. It's on our website. I made that probably 2, 3 years ago, but that information doesn't change. If you want to
mhm,
study amino acids, that is the highest yield thing on the MCAT. Enzymes and enzyme kinetics also absolutely critical. Protein structure in general, because keep in mind, enzymes are not the only types of proteins. We have structural
mhm,
proteins, we have
mhm,
transport proteins, all this other stuff.
mhm.
And then metabolism,
Right.
right? I would say biggest topic within metabolism is glycolysis, but
Yeah.
really you want to be familiar with the ins and outs of all of aerobic respiration. So the TCA cycle, the electron transport chain, ATP synthesis, and then you should be familiar with the accessory pathways. I can't recommend our metabolism podcast series enough. We
Oh,
had so much
so
fun
good.
with that.
Mhm.
But those are the things within biochem that really come to mind for me.
So high yield, right? And I totally agree. And not only is there biochem, but there's also general bio things, like things related to cellular biology. These are kind of like that intro bio stuff that you probably learned in like
Mhm.
first year undergrad, but they will come back again. So make sure to be familiar with them. These are things like organelles. Like go back to your basics. Remember, what's a
Mhm.
like no, remember what does the rough ER do? What does the Golgi do? What are vesicles? Like what are these things? Or go back to those
Mhm.
fundamentals. The nucleus. I mean, of course, you can't forget about the nucleus. What do these organelles, where are they? What do they do? The mitochondria, of course. Um,
Powerhouse of the cell.
the powerhouse of the cell. Maybe we're bringing that one back. Actually, it's funny. I did one teacher that hated that saying. But anyway,
Which is fair, but
um, be
yeah.
very familiar with transport as well in the cell. So like think about like anterograde and retrograde transport in the cell, your kinesins and dyneins. When you think about transport, oh, vesicles, oh, vesicles between which organelles? How does, what if I want to excrete a toxin? How does that actually happen? Make sure you're familiar with transport and even transports in and out of the cell in terms of like your membrane transporters, also very familiar with them. As well, and of course, we kind of referred to it before, signaling pathways, right? Be familiar with your signaling pathways, the key ones, really. I'm thinking about like G protein
Protein
coupled
coupled receptors.
receptors, yeah, like GPCRs, like that's a really key, like kind of not the whole way because there is some variation, but the kind of those first initial ones, you will be expected to know them. I mean, I guess that's one of the main kind of like signaling pathways that are like ones that you actually really should know. All the other
Yeah.
signaling pathways, be aware that they exist. Like you don't, I wouldn't try to hard step memorize them, but be familiar with how signaling pathways just work in general.
Yeah.
Also, as a complete side note, cargo cults is what I remember. Like there's like about cargo cults is what there was a passage on it, and then I saw a documentary about them after. Anyway, it was so cool. It literally just clicked. It like just anyway. Sorry, that was a
We knew you'd get there eventually, Mike.
it took me a second. But yeah, back on cell bio, like that was just like a those are
Yes.
kind of like the main three things in terms of cellular biology that I think you should really know.
Yeah. And of course, when we talk about signaling pathways, especially, there are more that you'd want to know, but that are not ubiquitous. They're not in every cell type. Like if we start to think about like specifically within like glucose regulation, like
Hmm.
okay, we could talk about insulin and glucagon signaling. Lots
Sure.
of hormonal stuff especially, but also like signaling between let's say the brain and the kidneys or like
Mm.
between organ systems, there's a lot
Sure.
of like intra or inter system signaling. I'm like,
Communication.
intra
Yeah.
is within. Yeah. So
Within. Yeah.
inter system
Yeah.
signaling, right? In general, you do need to know your organ systems. You do need to know physio as a whole.
Mhm.
It's less about the anatomy, right? You're not going to get questions about like what are the distal portions of X bone, like what do we call this particular bone that like has the little bump on your wrist,
Oh
right?
my,
Like
I hate it.
you,
I
you
just got the
don't
flashback
need.
from physiology, and I'm like, oh.
No, I mean, like physio is pretty much all tested. Okay. But anatomy, not really tested. Like gross anatomy, not really a thing. Okay. So you need to know organ system function more than like the literal structure. There are things that you want to know, like understanding the layers of membrane around your heart, right? The pericardium, things like that. Like, okay, yeah, sure, but it's pretty topical. Physio, you need to know how different body systems work. You want to know
Hmm.
how muscular contraction works. You want to know how hormones are released, why they're released, what their target tissues are. You want to understand how the heart beats, right? You want to understand the electrical system of the heart. You want to understand that the atria contract and then the ventricles. You want to understand the pathway of blood through the heart. Things like this, right? Most body systems are medium yield. There are a couple that are higher yield, right? I would say neuro is pretty high yield.
Hmm.
Endocrine is pretty high yield. Those are big too.
Yeah.
Most of them are medium yield. There are some that I think are slightly lower yield than others,
Yeah.
and
Like
that are
bones.
bones. I
Yeah.
would say immune system.
Mm.
More so, not that it's low yield, but it's just very topically
Very
tested.
surface level. Yeah.
And I think kind of straddling like that medium lower yield, aka just it's really complex and I don't think it's tested as much, is like the reproductive system. Like it is tested,
Yeah.
but it's
Hmm.
so complicated. So
Yeah.
like you want to be keeping that in mind as you're doing practice questions. You need to know all the organ systems. Okay, you
Hmm.
do. But there are some that you need to know inside and out. Again, my favorite is neuro because you could see it in all three science sections, but
Hmm.
you want to make sure that you are engaging with an MCAT
Hmm.
textbook and not just like an A&P textbook, an anatomy and physiology textbook, because you want to see those MCAT connections. You want to see those tutor notes of
Hmm.
like, or tutor tips like, hey, make sure you know this one in great amount of detail, etc., because they're really helpful for a topic as broad as biology, right? It's a
Yeah.
very
Yeah.
high yield thing, but
Quick shout out to our textbook, which is totally free on our website that has really specific tutor tips where we talk about
mhm,
these topics, but not only the topic itself, but how they can test you on it. Really
yeah.
great tips from tutors on how to be thinking, great mnemonics there. And again, I can't write, it's totally free. Check it out on the website. I think it's a really great resource to use. But that kind of brings us to kind of the final topic that I think is really, really high yield for BioBiochem, which is molecular biology. Now, these are things like DNA and RNA processes. These are things like transcription, translation, right? Talking about like regulation of these processes, when they're upregulated, when they're downregulated, how the regulation actually occurs via transcription factors, these sorts of things. But we also, that kind of falls under molecular biology. It's not only the topic of molecular biology, but how we study molecular biology. Things like PCR, blotting techniques. Oh, the blotting technique, especially like the Western blot. I've done a lot of Western blotting like in real life, scarred, absolutely scarred, but it is a very high thing to know not only how it works, but also how to interpret them is huge. Also plasmids. Plasmids don't come up as often as blots, admittedly, but you should know how a plasmid works, like the basics of like how we actually integrate DNA into a plasmid, why plasmids are even relevant in the first place. These sort of lab techniques on how we study maybe aren't tested directly, but are going to be ubiquitous in these biochem passages. When we talk about knocking out or introducing things, you're going to see these things in these techniques, so you should be familiar with them in order to interpret them. As well,
Yeah.
finally, and also hint the next topic, the topic of next episode, we're gonna be talking genetics. Be so familiar with genetics. Be very familiar with like what does that term even mean? Like how is it? Like with like really no like I mean that might be a very surface level thing to say, but a lot of things that gets overlooked, like what does it mean? Like what does genetics even mean? The ideas of like how DNA makes up everything. That is kind of the blueprint for the human body. How everything, every protein that we get, every RNA is from this blueprint. And we're going to be talking specifically next episode on Mendelian inheritance. I want to really focus on the term Mendelian because Mendelian has a lot of key assumptions, and that's what we're going to be focusing on, like how inheritance actually works and how to actually go about problems for Mendelian inheritance. That's going to be the real key focus of next episode.
Yeah, and it'll be fun because genetics is one of those topics, like immunology, actually, that like you could fall down an absolute rabbit hole.
Yeah.
Like people make this their entire career. Of course, there are cardiologists and there are like pulmonologists, but like especially in terms of molecular geneticists. I actually have a cousin who's doing her PhD at Northwestern in epigenetics specifically. We'll talk about some of those things next episode, at least to get you exposed to them. But like, this is something that is so fascinating. It's a very active field of biology. But on the MCAT, right, there are very clear lines of like, this is what's testable. That's what we'll talk about, right? Especially because it's something that is so fascinating. And we hope that you dive down the rabbit hole because why not? Right.
Yeah, I mean, you will eventually you will probably understand all of these things eventually.
Yeah. And like, we've talked so much about like finding the joy in MCAT prep today.
Mhm.
And I feel like when you find things that you're interested in, go fall down the rabbit hole, not because you think that they're going to show up on your test, but just for fun. It will help you engage. The genetics is such a fascinating field of biology. I'm really excited to talk about it. Again, we'll be focused on what genetics material can show up on your exam, but I might hint at a couple weird, cool
Weird
things that
genetics
are
things, maybe
rabbit
evolutionarily
holes that you
related.
could fall down.
Yeah. Absolutely. Really looking
Yeah,
forward
it'll
to
be a
that
fun
next
pathway.
episode. It's going to be really, really fun.
Yes.
So with that, thank you everyone. If you made it to the end of the episode, thank you for sticking around. This has been a fun one. We have a few tangents on this episode, but I think a lot of really fun tangents on this episode. But our goal is that our goal is that bio passages are a little bit more approachable, that you know maybe if you identified maybe in this episode why you're struggling. Maybe you're doing some of the things that we really don't like, but maybe we can shift those things. Maybe we can try out something new. If you're like Mike, Molly, all those things seem super, super hard, give it a shot and let us know in the comments how it goes. Let us know, give us feedback. We always love hearing from you guys.
Yes. Best of luck, you guys. Get lots and lots and lots of practice. Don't shy away from practice, right? And of course, come see us. Let us know if you need help with stuff. That's what we're here for. We want to make these episodes relevant to you. So until next time, have a wonderful rest of your day. Happy studying, and we'll catch you in the next one.
See you, everyone. Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
and Molly Hudash.